Hi everybody and welcome. Today we're going to be working on day 2 of our Unit 2 test review. So for today we're going to be focusing on equations with 2 variables, and we're going to look at the more challenging examples when we see elimination and when we see substitution. One of the things that we're going to need to be able to do for our test here is identify how to use either substitution or elimination, and we might even be told that we have to do one of the two. So we want to be prepared. Let's say if we're a substitution expert, we want to also be prepared to make sure that we know fully how to do elimination as well. So we're going to start off with specifically reviewing elimination first, and then we'll move on to some substitution examples. So systems of 2 equations with elimination specifically is what we're going to do. So remember to create 2 equations with matching variables, and we're going to want to make sure we also have different signs. So this is the key thing that held up a lot of us with success on elimination before. The last quiz, it showed basically a lot of us were really good at matching the variables, but they do have to have, I meant to highlight that, they do have to have different signs. So for example, off to the side here, if we have 5 and 5, well, 5 and 5 together gives us a total of 10. But if we have 5 and negative 5, when we put 5 and negative 5 together, that's how we get 0. And this is what we want. And the way that happens is we have a positive 5 and a negative 5. So they have different signs. So without those different signs, we're not able to actually eliminate anything. So in our first example here, when we look at these, x's together and y's together, equal signs together, everything matches, but unfortunately, 4x and 1x gets us 5x's. 2x minus 1x leaves us still with 1y, sorry. So nothing eliminates. So we have a few choices here. We can eliminate either our x's or our y's. But let's say we multiply our second equation by 2. So every single term by 2. So 2x minus 2y and 26. If we do this, the reason why this works is here's plus 2 and here's minus 2. They have to have different signs. If we don't have different signs, we don't have success. So just going to take our first equation here and recopy it. And now we're ready to combine. So 2 and 4, don't think about it as addition or subtraction, think about it as combining. 2 and 4 combined is 6. Negative 2 and positive 2 combined is 0. 26 and 10 combined is 36. So again, putting those together, being careful of our signs, that's how we end up with our answer here of x equals 6. So now that we have this, we're allowed to go back, and I'll highlight these in red. We can use this or this, either of those 2 original equations, and we can plug it back in. So I'm going to pause here and actually have you plug it back in and find out what is y. So again, either equation works for plugging it back in. Let's say we do the second one just to save some time. All right, so from here, subtract 6 from both sides. We get negative y equals 7, and then it's negative y, so there is an invisible 1 that's hiding there. So if there's not a number, we can always draw on that 1. So we'll divide both sides by negative 1 because we want y totally by itself. So negative doesn't work. So getting just y by itself, not negative y, but just regular y, leads us to y equals negative 7. So there we go. So that's our answer for this one, and specifically using our method of elimination. So now what we're going to do on the next page is take a look at substitution. So a couple of things here that basically are challenging with substitution, and it's generally when the variable isn't by itself. So remember, if a variable is not isolated, that means not by itself, you are allowed to manipulate the equation until it is. That's just a fancy way of saying if it's not isolated, move it around until it is isolated. And we are actually going to do the same example. So the same question, except we're going to do it with substitution. And if we do it right, we should get the same answer. And if not, we have some serious questions. So we're trying to plug things in. And if we see down here, we have x by itself and y by itself. So either of these work. And basically what we're trying to do is we want to get one of them totally alone. So a good candidate here would be x because it's positive, so a little bit less work that we have to do. And just like moving numbers around and all of the operations that we do to solve equations, we can do those same things without solving. And this time we're just getting x alone, we're isolating. So if we take y, the opposite of minus y is plus y. So we're left with x equals, and then here, 13 and y are not like terms. 13 does not have any variables, y obviously is a variable, so we're not allowed to add them together. So because we're not allowed to add them together, we can just write them next to each other. So we have y, and we have positive 13. So because we did that, now we are ready to substitute because x is alone. So that's the key, is we just had to get to a place where x was totally, totally alone. So now we're ready. We can go back to our original equation here, and we can plug in the place of x. So we have 4, and then instead of x, we're going to write in y plus 13. And then recopy everything else exactly as it is. So plus 2y and equals 10. So distribute, and then copy everything else straight down. So 2y equal sign 10, all those come straight down. And then now we look for some like terms. So our y terms are both able to go together. We can subtract on both sides, so we have 6y and negative 42. Divide by 6, divide by 6. Y gets us negative 7. So using that process, substitution this time instead of elimination, what we're looking for is first getting x by itself, and then after x is totally by itself, that's when we can go through and actually get our numerical answer for one of our variables. So now, once more, we're going to pause and have you plug in for x and see what x is. So one of the convenient things about having x by itself already is that a lot less solving. All we have to do is just plug in one term, and we're good to go. So again, we know what y is, negative 7. So x here, negative 7 and positive 13 is just 6. So there it is. We have two different ways of solving the same equation. We had 6 and negative 7 here, and we had 6 and negative 7 there. So they both work, same equation. But the thing we're focusing on in the video and the notes today is not necessarily on the answer, but more on how did you get there? What are the steps? So hopefully these two examples give you some very solid notes that will help you on our assessment coming up on Thursday. As always, thanks for watching. Let us know if you have any questions, and you're ready to start the practice.